collaborative robots. So,
yeah, so really the focus of this is on collaborative robots or cobots, but I do want to connect it into industrial IoT because frankly that's what my team works on is going out and finding startup companies that are doing interesting things in IoT, industrial IoT or enterprise IoT, and finding ways to use them to accelerate customer success. We're part of the P&I organization, so we're SAP IoT team. We're called the Development Accelerator, but that's another thing. So just to start out, robotics has been around for a long time. It's a discipline that's pretty well understood. In the month of May 2016, right, 13 robotics companies received 111 million in VC funding. Right? 4 were acquired for 400 million plus, and Medea, which is a Chinese robotics company, made a bid for KUKA, which is a German robotics company, of 5.2 billion. So even though the robotics business has been around for a while, there's a new round of investment that's happening in robotics, which, again, here probably isn't a huge surprise, but it really got going only a couple of years ago, this new collaborative robotics movement. And so that's really the focus of what I want to talk about. The little picture up here, this is Shaky from SRI, Stanford Research Institute here in Palo Alto, 1968, 1970. So robotics was just around the corner in 1970. It drives itself, it reasons and figures out how to get from point A to point B. If you've ever done some coding with like the A-star algorithm, my understanding is that it was created to make Shaky move around the room. So that may or may not be true, but that's what I've heard. But SRI is still doing robotics today, by the way, and they're very, very cool, what they're working on. So if you're geeky like I am, you probably have read ahead to 2058 and know exactly what the laws of robotics are, right? No, it's not going to work. There we go. And thankfully, our friend Isaac Asimov in 1950 looked ahead as well and said, you know, we need a zeroth law, which is robots shouldn't kill humanity, which, thank goodness, now we can avoid Skynet. So collaborative robots, actually, there's a timeline here from around 2003, the idea of collaborative robots started being talked about in the robotics industry. But in 2011, the first ISO standards for collaborative robots were delivered. And there's actually a new round of standards and specifications planned for early 2017. And they're big, long, complicated things, but it really boils down to that collaborative robots have to do a few things. They have to have mechanisms to limit the force if they are to come in contact with human beings, to look for obstructions and things and try not to run into them, that sort of stuff. They have to be programmable by normal mechanisms, and the term they use is hand guiding. The idea that you would mimic a human behavior, the robot would learn that behavior, and that would be the work necessary to program that robot to do that task. And so that's the like I said, boils down the core of collaborative robots. Okay, now I'm figuring out my mouse. Okay, so this is probably pretty close to what we think of as, what we think of when we think of robots, right? The big assembly line, robots going on there. What do you notice in this picture? We've seen these kinds of robots. What do you notice? What kind of is surprising? No people, right? So that's a very common situation. What would happen if you walked out on this line while it was running? What do you think the outcome would be if you just crawled up on top of that car and sat there? What would happen?
It would be integrated into the car.
You would become part of the car, you would not enjoy it. Yeah, it would be an absolute mess, right? Because they would kill you, right? There's safety and things like that, but there's really no mechanism in this environment where a human interacts with the robot in the process, right? And the other way you see it is big yellow lines around things, cages around things. They're designed that way for a reason. These big arms swinging around will kill you, right? And I say it like that because even as I was trying to figure out like what's really different, it wasn't until someone at ABB Robotics just plainly said it that way. What's the difference between collaborative robots and other robots? Collaborative robots won't kill you. Simple as that. Now, obviously, it's a little more complicated than that. But if a robot is an autonomous item that you can that senses its environment and uses inputs to then accomplish a task or a goal, then collaborative robots are the same, except for they're meant to work in and around human beings, right? They're meant to collaborate with workers. So one of the things that I think is there are all different types of collaborative robots, but again, the idea that they work in and around people, they do a similar job to what a person does. What I think we're finding is that there are many use cases that robotics, the traditional robotics, didn't really apply to, that now collaborative robots do apply to in respect to our industrial or enterprise customers. And so there's another key point I want to make here, which is, and this is going to the IIoT aspect, which is, if we think about IoT as devices delivering just a massive amount of data, and then we're analyzing that data for insights, right? There's value in that. But the real value that SAP has a real opportunity for is actually driving actions, process and actions, and business outcomes. Well, action and outcome is not the same thing as data and analysis, right? Action and outcome requires automation. It requires robotics. So we may think of it as a valve opening and closing from an IoT perspective. That's an action and an outcome. I suppose if the plant gets water, right? But you have to actually go a little further. The more complicated use cases, you end up with robotics. What can we learn from robotics that applies to IoT? Again, I was talking about the automation. Robots are sensors, actuators. They are the devices that we talk about in IoT that we're trying to give voice to when we talk about IoT. It's just that they're better integrated. They're more complicated. They do a lot more local processing. But again, all the more complicated IoT scenarios require a mix of local processing and decisions, edge, core, these concepts around getting data and doing something with it, and then causing some sort of outcome. Computer vision is also another major area that is in IoT. It's important in IoT, and robotics is way ahead of the rest of us in terms of doing computer vision type stuff. So there's lots of stuff we can learn. So here are some, you saw the scary, it'll kill you robots. Here are some collaborative robots. On the left-hand side, Rethink Robotics is a startup that has two robots, one called Baxter, one called Sawyer, see, they're friendly, they have eyes, they smile at you. The ABB also has a really nice robot called Yumi, which is you and me, right? It's literally meant to work alongside people. They all are. Both of these are great examples of some of the aspects of collaborative, and so I'm using the ABB sketch as an example. The gray and, more of the gray, but some aspects of the black and red on Sawyer are cushions. They're soft material. If the arm swings and contacts a human being, it's padded. It reduces the impact. But it also has cameras based in the parts themselves, in the arms themselves, so that it can do computer vision on one activity and computer vision on another activity with two different arms. And it can detect if something's entered its field that's unexpected and respond to it, right? So your hand goes in and it's supposed to be putting something in. It will see that your hand is there and it will stop. And that's the key point, is it has to stop or avoid. It has to follow Asimov's laws, right? So we're getting closer there. Made of lightweight materials, these don't tend to be huge robots. The ABB robot is, I would say, slightly smaller than a, like my size torso, so I'm kind of big, so, it's a little smaller than that. Its reach is a little smaller. It's not going to carry 50-pound bags of beans around and throw them around. It's for finer work. Sawyer is really the same thing. You can put different grippers and things on that, but at the end of the day, it tends to be smaller things. But when they really get going, they can work very fast. And the thing that's really fun to see is when something happens, how fast they also react to avoid causing harm. And the 2017 standard, ISO standard that's coming out, this one I mentioned before, actually talks about the amount of force that it is okay to hit a human with a robot to not cause pain or physical harm. And people have been studying this now for years. I guess they've been in colleges, you can sign up for $20 and get hit by a robot, and they figure this stuff out. But it's taken them a couple of years to get to that point. But it's coming, and it's really good news. So we want to do demos, and I'm trying to keep track of time here. I want to do a simple demo of a collaborative robot. It's one from a company called Fetch Robotics, which is local here in the Valley, another startup. Fetch Robotics is basically building solutions that they're collaborative robots, so they're meant to be in and around people. They're primarily in like manufacturing or warehouse settings. The idea that they're working in and around people, but in an industrial setting. And they're mobile. Not all, the two robots I showed you before are not actually mobile. You can roll them around somewhere and put them in a new place, but they're not going to self maneuver. Fetch, with its particular robot called Freight, is a mobile robot. It's actually a pretty simple robot in terms of its structure, but it's the inside that's really cool, just like people. So we've been working with them. The team's been working with Fetch for a couple months now, building out a use case with extended warehouse management, integration with HCP, HCI, controlling the robot in the robotics controller, interfacing with the robotics controller, like it would be on premise in a warehouse, and integrating that with ERP, again, either at this room this morning around 8:30, 8:40. Took about 10 minutes tops to do. It took a little bit longer because people kept walking in front of the robot while we were mapping. But we mapped it out. Here's the robot, it's around the corner over here. And now I need you to use your imagination. We're in a warehouse. This is a warehouse location, and that's the shipping location, the other blue dot over there. So, as part of the demonstration, so I've got my iPhone here. This is an HCP app. It's pretty straightforward. And I'm going to tell the robot from wherever it is to go to this particular warehouse location by hitting a button. I need to look over here. In back, you may need to stand up. Gosh, I really hope it goes. No, one sec. Okay, so what it's doing right now is it has the map, right, and it knows where it's supposed to go, but it's constantly checking to see, is there anything I'm about to run into that wasn't on the map? So it knows places to stay out, but it's got a 3D camera, just like the HoloLens and the folks that were talking about the VR stuff. It's the same technology. So now let's say we've picked stuff off the shelf and we're done, and we want to go on to our next task, and we want to send this to the shipping department. I'm going to ask Hardik, because he works for me, to step out maybe around right there. Hardik is not on the map. So Hardik is a human being, trust me, and he probably will not be killed. The idea is that we will move it over here. All these people standing here will need to get out of the way as it gets closer, because it will stop to try not to kill them. So I'm going to go to shipping, and it should, yeah, it's good. And so you'll see different behaviors happen. It's trying to find, can I avoid, oh, it's going to take it out for sure. No. So it's trying to find its way through, and it's going to try to get over by those TVs over there. But the key is that the motion that you're seeing is that constant checking to see, has someone stepped in front of me? And so the only other thing that I wanted to show, anybody actually work on HCI and HCP in terms of development here? The UI for it? No? Anybody? Nobody? Okay, then I'll tell you. I actually think this is a great example of virtual reality as well. Oh, my session has expired. Of course it has. I will be done in just a second. See the little green dots up there? See how everything's great? All my connections, this is the HCI administration, all my connections are wonderful. Turns out the virtual part of it is they want you to feel happy about your HCI connection, so they make everything green. But if you actually use the function check, then a bunch of them go red, because that's when you really want to know. Otherwise, you should just relax. So, so I want to give time for questions. So, and I know we're short on time.
Yes. Now, thank you, David.
Sure.
We can allow 1 or 2 questions. So, questions in the audience. Up there, good shout.
Yes.
Hi, I just want to know, is there a place we can visit where those robots are actually working?
You mean like in a warehouse setting? So we are in the process of putting, and I don't know if you consider this can you go or not, we're putting these fetch robots in a warehouse in Rote, which is a demonstration warehouse that SAP has set up. That's one place we're going to do it. And that will be a full-blown demonstration with all the fun stuff. That will probably be in the next month or 2. So you, customers, anybody who's going to Waldorf can head over to that. As far as doing it here, it'll probably be later in the year that we will try to set up a more interactive robotics lab for people, partly because we're going to bring in a lot more robots. Now, we have the Fetch robot. We actually have one of the Rethink Robotics robots here in Palo Alto. So give us 6 weeks, 2 months, something like that. We'll have at least those 2 and maybe 1 or 2 more set up. But we're not going to probably go through the whole warehouse kind of setup. It's more like use your imagination like we did here. Any other quick questions?
One more? If not, David will be around, right? So you can find him. The robot will be also in the D shop later from 2 to 4:30, so you can check that out in building 9, first floor. Okay, thank you, David.
Thank you.